Okay, let's unpack this. Our mission today, well, it's a deep dive into the Nix ecosystem. The one that promises to finally solve those eternal headaches. Dependency hell, configuration drift.
And that classic, well, it works on my machine.
Exactly that one.
Yeah, and what's really fascinating here, I think, is that Nix doesn't just, put a bandage on the symptoms. It goes deeper. It uses this radical shift, pulled straight from functional programming. Think purity, immutability.
Right.
It basically treats the whole operating system not as this messy sequence of commands changing things all the time, but more like a value, something definite, produced by a pure function.
Okay, a value. So we're looking at sources explaining how this actually works, how it makes a system, reliable and reproducible for you, the user. But let's zoom in first, the core idea. If everything has to be immutable, how does Nix stop, say, one version of a library messing up another one?
Oh, okay, yeah. That's where the real magic is.
Yeah.
It lives in the Nix store. It's usually a Nix store, and it's content addressed.
Content addressed.
Meaning every single thing, package, file, tiny dependency, gets put in its own unique folder. And the name of that folder, it's generated from a cryptographic hash.
A hash of what, though?
Of everything that went into making it, right? All its inputs. So the source code, yeah, but also the build script, and crucially, the exact versions of all its dependencies. Everything.
So the path is the identity. That hash locks it down. And here's where it gets really interesting, right? Because that path includes the hash. Different versions of the same software, maybe Firefox 33.1 and Firefox 34.0.
They get totally different paths.
Yeah.
Completely separate directories in the Nix store.
So they can just coexist, no fighting over files.
Exactly. That physical separation. That's what definitively solves dependency hell. They literally can't interfere.
Okay. And this purity thing you mentioned.
Right. Critically, Nix enforces that during the build process. It builds software inside this really restrictive sandbox.
How restrictive?
Like no network access by default.
Mm.
And it can only see the dependencies that were explicitly declared, the ones included in that input hash.
Yeah. So no sneaky downloads or relying on something that just happens to be installed globally.
Precisely. That forces you to be explicit about everything. And that's how it tackles the "it works on my machine" problem. If it builds, it's because all dependencies are accounted for, period.
That makes sense for packages. Physical separation, strict builds, but looking at our sources, it seems like once you have that power, that immutability for packages, the next logical step is just, well, why not apply it everywhere?
Exactly right. And that's the leap to nixOS.
Yeah.
Now you're talking about the entire Linux distribution being defined declaratively. Usually in one single script, you can version control the configuration.nix file.
The whole OS from one file.
Pretty much defines the state, yeah.
Yeah.
And zooming out a bit, what this declarative approach gives you in practice is amazing rollbacks. Instantaneous, almost.
Right, I read about this. When you update nixOS, it doesn't just patch the running system. It builds a whole new complete system generation side by side with the old one.
That's it. And then it just atomically switches a single symlink to point to the new one.
Atomically? Meaning it happens in one indivisible step.
Yep. So if that new generation is broken, maybe doesn't boot, or something's wrong, you just reboot. And the bootloader lets you select a previous known good generation.
It's like Control-Z for your entire operating system.
That's a great way to put it. And this level of reliability, it enables serious scale. Look at Replit, the cloud development platform.
Yeah, they went all in on Nix, didn't they?
They bet big.
Yeah.
Reports say that they maintain this massive, 16 terabyte shared Nix store. It's read-only, and it gets mounted into every single user's container.
16 terabytes. Shared across everyone.
Yeah. Think about the deduplication. And it means packages are basically instantly available for millions of users in their isolated environments. It's pretty wild.
Okay, but to make that kind of sharing, that reproducibility, really work consistently across different projects and teams, that sounds tricky.
It was, and that led to the development of Flakes. They're now, pretty much the standard way forward.
Flakes, right? So what do they add?
They essentially provide a standard structure and, crucially, a locking mechanism. There's a slake.lock file, kind of like package-lock.json, if you know Node, or cargo.lock in Rust.
Okay, locking dependencies.
Exactly. It records the precise, immutable version, usually a git commit hash of every single input, every dependency flake. This is what makes a Nix project truly hermetic, sealed. It guarantees reproducibility right down to the bit because all the inputs are fixed.
I have to say, though, hearing about how strict this purity is, how different the whole model is, it
Right.
sounds like there's a catch.
Well, yeah, that raises a big question. If Nix is so powerful, why isn't everyone using it already?
The learning curve.
That's definitely a major hurdle. It's steep because Nix's whole philosophy, its purity, fundamentally clashes with how most existing software is built, with lots of implicit dependencies and side effects.
So stuff often needs fixing to work with Nix.
Often, yeah. It might need patching or wrapping in special scripts to make it behave purely within the Nix sandbox. And historically, the documentation has been a bit fragmented too, though it's getting better.
So the community's focus now is...
A lot of it is on stabilizing these newer features like flakes, improving usability, making the tooling better, and importantly, smoothing out the integration with existing package ecosystems. Think NPM, PyPI, Cargo, making it easier to bring those packages into the Nix world reliably.
Okay, so bring this all together. What does this actually mean for you, the listener? It seems like it means thinking about your whole system, your environment, completely differently. Not just as like a series of commands you run that change things.
Right, but as a single compiled thing, a piece of software itself derived from its definition.
The whole OS as compiled code.
Yeah. Which leads to a final, maybe provocative thought for you to mull over. If your entire operating system really is just a functional value defined purely by a single script, how radically could that change how you think about the security, the reliability, the trustworthiness of everything you build on top of it?